warahmatullahi wabarakatuh, and a very good day to the respected panel, Dr. Nur Hanis binti Muhammad Razi and Professor Madia, Professional Technologist Dr. Asma Rashid bin Ponirin. My name is Ahmad Wafi Taqiuddin bin Eusud, supervised by Professional Technologist Dr. Ahmad bin Muhammad No. Okay, for this final year project 1, I will present about the report title of Development of Web Application Package to Size a Grid-Connected Photovoltaic System. And I will explain about the research award through this research. I won the Gold Award for the National Innovation and Invention Competition in Youth 2021. Attached below is the certificate of award that I have won in this competition. Okay, let's go straight away to the introduction. So, electricity, its demand has been increasing year by year, and its generation is highly dependent on the fossil fuel that always produce CO2 emission in the environment, which is not very good. So, based on this newspaper, it says I will betray the planet because of the CO2 emission. And then, because of this CO2 emission, we have to use the photovoltaic system because it has the potential to design a future electrical system that is clean, reliable, and scalable. Then, due to its high efficiency, PV creates electricity from sunlight and transforms it to electrical energy. So, based on this newspaper also, it said doing good with solar power, and of course, everything has pros and cons. And the cons is that it is very dependent on peak sun hours, temperature, weather, and others. And then the PV capacity, inverter, and load need to be sized precisely. So in conjunction with it, it has to do a lot of complex calculation with along the computational sizing method. So by developing a web application package, it is easy to sizing the PV system. So the user can easily size the PV module, inverter, and etc. So for the objective is the first to size the grid connected photovoltaic system for single story terrace house. Second is to develop web application package. Third is to compare the result with the computational sizing method with the web application package. And the scope is that the focus will be on the single story terrace house, and the MATLAB will be used. And the third one is the climate condition is based on Malaysia condition. And for the literature review is firstly, according to the FKREO, it says in their article that in this article, it explained about the web application package for the standalone. So the difference between my final year project and their research are of course the location and the photovoltaic system, which is in this researcher they use the standalone, and in my research I will use the grid connected system. And then secondly, according to the Shahri Irwan Sulaiman, they comes with the idea of sizing the grid connected photovoltaic system using generative algorithm. So the differences is that I will use the web application package, but for the sizing grid connected, I will try to apply the calculation in my project. And lastly, according to the NEM by Saddam Malaysia, NEM stands for the net energy metering. So for this, I will compare the calculation with NEM. Okay, next is the methodology. And this is the flow of the research. For the PSM1, which is I doing right now, I will do the literature review and discover more information regarding the sizing of PV system and do the data collection for single story terrace house and grid connected PV system using computational method. And if I don't satisfy, I will go back to the data collection to find out effective data. Then is if I am satisfied, I will go straight to the development of application package, which is for the PSM2. And then for the data collection, the location of a single story house, the area of the house is 6 times 21 meter, and the rooftop can be fit with 4 PV panels of 5 times 2 meter. And this is the location of the house, which is located at Jalan University beside the UTSM. And this is the location of the house. And the second one, this is the load consumption. Load consumption. It consists of 13 different types of load with the different estimated power and total load connected. And the third one is that the temperature of the STC is 25 Celsius, and it contains various complex steps of calculation. Okay, next is for the preliminary results. Okay, for the preliminary result, and this is the load analysis and energy consumptions with 13 different types of load with different demand factor, different maximum demand, different daily usage, and different energy consumption. And of course, for finding all these numbers and the value, it contains various type of equation that I provide in the report. So for the daily energy consumption, I got 70,088 watt per day, and for the monthly, I got 513 kilowatt per hour. So that is for the monthly energy consumption. And for the computational sizing method of sizing photovoltaic system. Okay, firstly, I will explain about the how I get the array guaranteed power output of 1377 watt. Okay, first I will go through the PV panel rated DC output, which is I decided to use 355 watt with the manufacturer power guarantee of 0.97, and the number of panel in array that I have mentioned before, which is 4. So I got 1377 watt. So for the temperature corrected array power output, I achieved 1352 watt with the value of array average temperature of 30 Celsius, and the temperature coefficient for power is 0.0036, and the STC is 25 Celsius. And for the net array power output is I got 1311 watt because of the array wiring and mismatch losses of 0.03. And for the inverter, maximum AC power output, I achieved 1219 watt. Okay, for the inverter, I decided to choose 1500 watt because it is more bigger than the PV out array. So with the inverter power conversion efficiency 0.93 and the inverter MPP efficiency is 1. So for the average daily and monthly energy consumption, I will use the average daily consumption, which stands for peak sun hours of 4 hours. So I got the daily is 4,876 watt per day, and the monthly is 146 kilowatt per hour. And this monthly energy production 146 kilowatt per hour is for the PV module. So based on the NEM, I got is that the actual bill before implementing the solar panel is 186 and 91 ringgit, and the exported energy of the PV panel which is from 146 kilowatt per hour, I got 75 ringgit and 34 cents. So hence, I got the total monthly saving is 111 and 57 ringgit. So hence, through all this FYP1 research, it can be concluded that I concluded that objective one has been successfully achieved. Okay, that's all for me. Thank you.